Okay, so today we're going to be starting a new topic in physics. We're going to be talking about work. And if you can go ahead and look in your chart, I'm going to be giving you the definition of work so you can fill out in the upper left-hand corner while I write. So, work is defined as the force that acts to move an object. When everybody copying this down, Dorian, copy this down.
He told you.
Damn.
I'm going to go ahead with that deal. And like every word in physics, like every definition, there's always an equation that goes along with it. So we can define work in equation terms as W equals F times D. Now, who wants to tell me what the variables F and D are? We've worked with them both in physics. Cordell.
Force.
Force, very good.
Distance.
Very good.
That's what that is.
Take 5 seconds and copy that down.
Listen here, you go to classes today.
That's right, Craig.
Cordell,
I know I need a pen. I need a pen. Listen, I don't got a pen.
you don't have a pen?
Apologize.
Oh, no.
When Cordell second copy it down. Now, a key thing I want to point out in this definition is that in order for work to be done, or in order to do work, you need to have a force and you need to have a distance. So in other words, this is saying you have to have a force that moves an object. That is the key. Now, I understand that work is sometimes done in like colloquial terms. You could say, oh, I did a lot of work today. But work means something very specific in physics. It means that you've applied specific force to an object and it's moved a certain distance. Now, if you look right under the chart, I want you to look at this key point under here. And it says that you can exert a force on an object, but it doesn't mean you are doing work on an object. So right now I'm differentiating between force and work.
You just exert a force on an object?
Right. You can exert a force on an object, but it doesn't mean you are doing work. Force is only a push or pull on an object resulting from the interaction with another object. So before we differentiate between force and work, I want somebody to give me an example of a time they did work. Cordell.
When I push Dorian's head forward,
Right.
force to
And how do you know it's work?
I just put in work still.
Cordell, how do you know that pushing Dorian's head forward
Because
is
that's
work?
force. It's a push or pull.
It's force, and what is the other element of our equation?
Distance. It's moving
Right.
forward.
Exactly.
You really
So-
let him use that as an example.
It works. It works. Makes Cordell happy. So Cordell's applying a force, and it's moving a specific distance. So that's how you know it's work. Can we model something again? I don't need to move your head when Cordell.
Yo, if he touch my head, I'm gonna hit him. I'm just telling
Okay.
you.
Okay.
You ready?
Dorian, stand still. Yes.
Yo, I'm not playing. You touch my head, I'm gonna hit you.
Okay.
Anyway, touch the shoulders.
Okay.
I
This
think
is
my
just
Reese's
not a
are
good example.
16. I'll eat Reese's.
Alright, all eyes on me in 5, 4, 3, 2, 1. Okay. As that a little rough example illustrated, is that when Cordell used his hand to touch Dorian's head again, he applied a force, but Dorian's head didn't move like it was before. So that's just an example of force. And even though Cordell feels like he's doing work, he's not actually doing work.
Nah, I don't get it.
Oh,
Because Dorian's head didn't move at all.
Oh.
There was no distance that happened, so that's just force.
See, they go back.
So now I want you to take 1 minute and on your own in this diagram, I want you to draw an illustration of work and what that means to you.
What did you draw?
I drew picking up a shopping bag on my way home.
The only one I did.
It's a little rough, whatever helps you remember it. And then I want you to draw a diagram of when you exert a force but you're not doing work. So take 1 minute and do that by yourself.
So would this be when I'm pushing the ball?
Very good. I'll ask you to share in about 45 seconds.
1, 2, 3. Come on, man. You should see his drawing.
See, it's only one.
30 seconds. Dion, I want to see those illustrations.
Oh, I think you was drawing there.
Good morning.
All right, 15 seconds. I'm going to ask people to share their pictures that they wrote with us.
The Cordell go first. I go first.
You volunteered a lot today. We give some other people some opportunities.
I'm gonna go first.
can I read this example?
Because you don't know I get it.
Right here, so I'm just-
Okay, I want somebody to share their diagram of work and a force. Dion,
I got a person.
describe us your example.
That a person pushing somebody else to define a force.
Right. And is his head moving, or is the person moving?
Yeah.
That's so childish.
So creative. Football. You don't play football?
Huh?
All right, let's start with your illustration of work. What's happening in that? Use it. Talk to me in physics terms. Talk to me using this equation.
Alright, so the ball is gonna work because he's applying a force which is making the guy fall, so like it's that he's
Right.
moving some kind of distance.
Very good. And talk to me about your second illustration now, the one of only force, and where he's not doing any work.
He pushed him, but he didn't really move all like that.
Right.
It was like a nudge.
A nudge.
Yeah.
But did the person who's being pushed, did he move at all? Good. So why doesn't he move?
Because it was no distance.
Right. Very good. Well, why is it not work?
Because it was
No distance. Very good. I think we all understand. Okay, I'm gonna jump really quickly to this characteristics box. So when we talk about work and when we solve for work is in joules, and that's represented by a big J. I'll spell that out for you. Joules.
Who called you?
And when we do work, it can either be a positive and a negative number.
Where are we supposed to be right now?
In the characteristics box,
Really? I don't know that equation.
and we know we've talked about positive work. This is what we've been talking about. The force causes the displacement.
I'm sorry.
But when we talk about negative work, we're talking about the force hindering the displacement. So that's a little confusing. I'm going to give you an example. When you're driving a car and all of a sudden you realize somebody's in the crosswalk and you slam your foot on the brakes, you're actually doing negative work on the car because you're applying a force that hinders the displacement of the car, so it's not going as far.
Some people don't stop when they see people walk across the street.
You should.
You should. Fuck it, don't stop.
So that's actually hindering the displacement.
So like stopping something from moving would be a negative word.
Right. When you're applying force to stop something from going that full distance, that is negative 1.
Alright, so like me putting clothes in my cart, stopping the cart would be negative. You know what I'm saying?
Right. Very good. Very good. Very good. Okay, we're going to transition quickly. Flip over the page. We're going to work through some problems together. Everybody have this down. I'm going to go ahead and erase it.
What happened?
I said FaceTime to him.
So you said the units for work is gonna always be joules?
Joules.
Okay.
It's represented by J.
Okay.
Okay, so let's go over this first problem. So we're looking for work, and we know that the force is 6 newtons, and the distance is 5 meters. Dorian, you're going to walk us through this first problem. How would you solve for W? Work.
6 times 5.
Very good. Because you know the force is 6 newtons, and you know the distance is 5 meters. So what's going to be your final answer with units, Dorian? 30. 30 what?
Joules.
When you have something to say, please raise your hand. What is it going to be, Dorian? So 30 joules. Does that make sense to everybody?
Yes.
Yeah.
It's simple multiplication.
Very good. I know. I just want to make sure that we have the basics before we go into some harder